I can still do this.
Okay. Okay, let's start from the second one.
Okay. So minus 16.
What is a minus times a minus?
Plus.
And
So it would be 16.
Yeah. And when you square a number, you can never get a negative because of minus times minus making plus. And next one.
64.
Too big.
Oh, or just 2 times 2. Oh, 16.
Yeah. And last one.
Just 5. No, 1.
Yeah, that's it. Any questions there?
No.
Okay. Do you already know how to divide indices? Do you already know how to do this last one?
Yes. So it'd be 7 minus 3, which is 4. So 5 to the power 4.
That's great. So to divide indices, copy the base, subtract the powers. What would be the one on the middle left?
M to M squared.
How about top middle?
H to the power 5.
And top right?
G minus 7 to the power of 6.
Well done. Yeah. Okay, you've got it. Fine there. So I can divide indices x a half or tick?
Tick.
Yeah. What would you get if you divided these two?
A to the power 1.
Yeah. A to the power of 1 and what is that in its simplest form?
1.
Or you've got 3 A's on top, 2 A's on bottom.
Just,
yeah, go on.
it's just A.
It's just A, yeah.
Okay.
And so if you have x by itself, that's the same as x to the power of what?
1.
Yeah, so it's a bit like 1x. Same idea. Okay, how would you do this top blue one? Or what would the answer be?
B. A. Wait. 4A to the power of 3.
Well done. Yeah. So normal number divided by normal number, and then same letter divided by same letter, but the way you divide indices is still to subtract the powers. So a mixture of dividing and subtracting. Okay, how about this?
3x to the power of 2, and then y to the power of 4.
That's it. Those are the exam questions. Let's do bottom right.
Be 3a to the power of 4.
That would be 5.
To the power of 1.
So this a appears to the power of 1. This is 5. And so it's not 5 minus 1, it's 1 minus 5.
To the power of minus 4.
Yeah.
And then f to the power of 6.
Well done. Let's try top right.
1 m to the power of 2. No, minus 2.
Yeah.
And then t to the power of 4.
T to the power of 4. And you know how m is the same as 1m? So, so the number in front down here, what would it be?
1.
So this is 2 divided by 1?
Oh, 2.
That's it. Yeah. So a mixture of dividing and subtracting. That's the trick there. Okay, how about this one, top left?
5a to the power of 4, and then b to the power of minus 4.
So
3.
So what is it, b to the power of?
B to the power of minus 3.
So this is b to the 4 on top, b to the 1 on bottom.
B to the 3.
That's it. Okay, I can divide indices with 3 terms. What would you give yourself?
The middle.
A half, or in between a half and a tick, do you mean?
Yeah, in between those 2.
Oh, okay. Like 3/4 maybe.
Yeah.
What would this one here be, this blue one?
1.
Yeah. Any number divided by itself is 1. And what would it be as a to the power of something?
0.
Yeah, and that just shows you that any number to the power of 0 is 1 because it must have been divided by itself. So top left one?
1.
Top right?
1.
And bottom right?
1.
Yeah. I can raise indices to the power of 0?
Tick.
Yeah. Okay, let's try these. 3 times a third.
1.
2 times a half.
1.
A fifth times 5.
1.
So what would go here then?
Times an eighth.
And the bottom one?
Times a seventh.
That's it. And so there's this word reciprocal. The reciprocal of a number is what it must be multiplied by to make 1. So the reciprocal of 8 was 1 over 8. The reciprocal of 1 over 7 is 7. So write down the reciprocal for each of these.
1 over 6. 1 over 11. 4. And 9.
That's it. And maybe I should point out 6. What is 6 divided by 1?
6.
Yeah, and so you can write that as 6 over 1. It's the same thing. Its reciprocal is 1 over 6. And you'll notice that's true for everything. 11 over 1, the reciprocal is 1 over 11. 1 over 4, the reciprocal is 4 over 1. And so you just flip the fraction. Okay, what do we get here?
1.
How about top right? I want to go here.
13 over 6.
That's it. Okay. Let's try these. So write 1.6 as a mixed number. What would that be?
B.
Or as a fraction?
B. we I can't remember how to do it.
1.6. So you know how the 0.6 is in the tenths place.
Yeah.
So you write it as 1 and 6/10. Can you make that simpler?
1 3/5.
Yeah. Can you now turn that into an improper fraction?
4. No, wait. Yes. 8 over.
Yeah. 8 over.
5.
So that's 8 over 5. And using that answer, find the reciprocal of 1.6.
5 over 8.
Well done. Equals 5 over 8. And so the way you find the reciprocal of a decimal is you turn it into a fraction and flip the fraction. Okay, so reciprocal. Let's try part C.
The screen is frozen.
Oh, sorry. Might just take a second.
Okay.
What is it doing?
It's just frozen on the 1.6 in its simplest form.
Is it still on that?
Yeah.
I'll try.
So that's 4 and 8/10, which is 4 and 4/5, which is 9 over 5.
How did you? So that would be if it was one.
So 24 over 5.
And so it's reciprocal.
5 over 24.
Well done. 24. And how about the last one?
3 over 2.
Yeah, 3 over 2. Got it. Exam questions. How about the one on the left?
1 over 5.
And how about the one on the right?
That'll be 1 and 25 over 100.
Yeah.
Which is 1/4. So then that would be 5 over 4, which, so the reciprocal is 4 over 5.
Equals 5. 4. Sorry. Any questions there?
Nope.
So you got that first shot. So I can find the reciprocal of a number.
Tick.
Okay. Let's just. Can we do this a quicker way? Let's just do the thing on the right. 8 to the 3. Sorry, x to the 3 divided by x to the 5. What is that?
X 3 minus 5, and then x squared.
What is 3 minus 5?
Oh, minus 2.
Yeah, so it's to the minus 2. And then they wrote it a different way. 3x is on the top, 5x is on the bottom. What is x divided by x?
0.
That's
1.
Yeah, any number divided by itself is 1. And so, what are you left with?
2x minus
What is x times x?
X squared.
So on the bottom you have x squared. Any idea what you have on the top?
0.
You have the 1, because x over x is the same as 1 over 1. So it's like 1 times 1 times 1, which is just 1.
Oh.
Let's see. Okay, let's try the one underneath it.
So 3 minus 4, which is minus 1.
Mm-hmm.
And then x. No, 1 over x.
Mm-hmm. And so x to the minus 2 is the same as 1 over x squared. X to the minus 1 is the same as 1 over x. And so x to the, let's say, minus n is equal to what?
1 over n squared.
1 over x to the plus n.
Oh.
So let's say 10 to the minus 3 is equal to what?
10. So in what, like?
Or let's say a to the minus 3. What is that?
So
How could you write it as a fraction?
a 1 over a to 3.
Yeah, well done. And so you make it 1 over, and then you flip the fraction. Let's say if it was x to the minus 7.
1 over x to the 7.
Well done. And what you'll notice is basically a is the same as a over 1. A divided by 1 is a. X is the same as x over 1. And so it's just the reciprocal. You're just flipping it and getting rid of the minus. So that's what the to the power of a minus does. It makes it the reciprocal. Okay, what are these two?
1 over h to the 3.
Yeah, so it's like the reciprocal of h to the 3. And what is this one down here?
1 over t to the...
Sorry, we haven't done that yet. I shouldn't put that there. Or I need to do something else. Okay, exam questions. Let's try top left.
1 over 5 to the 1.
Can you make it simpler?
1 over 5.
Yeah. How about the one underneath?
1 over 5 to the 2.
Can that be simplified?
1 over 25.
Well done. Yeah, that's simpler. So the next one?
1 over 3 to the 2, which is 1 over 9.
And how about bottom right?
1 over 2 to the 3, which is 1 over 8.
Well done. Any questions there?
No.
Okay. I can simplify indices with negative powers.
Tick.
What's the answer here?
2 to the 11.
Yeah. What would be the middle one?
X to the 6.
And the one on the right?
Oh, 2 to the 6.
Yeah.
So 6.
I can multiply indices.
Tick.
Okay, let's try the top one.
So 6 to the 6A to the 8.
That's it. How about this one?
20 x to the 5, y to the 9.
Well done. Let's try bottom right.
28 a to the 4, b to the 3.
Well done. First shot. I can multiply indices with 3 terms.
Tick.
Let's try top right. Oh no, sorry. Better start with top left.
So 5 to the 7 over 5, which is 5 to the 2, 5 squared.
Can you make that simpler?
25.
And the one on the right.
8 to the 8 over 8 to 7, 8 to the 1, which is 8.
Well done. Okay, exam questions. Let's just do top right.
P to the 7 over P to the 2. It's P to the 5.
That's it. I can multiply and divide indices.
Tick.
So this one on the left, what would this be?
So 2 to the 6.
Yeah. And what is the quick way of going from having 2 and 3 to just 6?
Times the indices.
Yeah. And so to raise an index to a power, you copy the base and multiply the powers. So what would be A?
2 to the 12.
That's 2 to the 12. How about C?
6 to the 10.
Okay.
Oh, wait, no, it's B.
Yeah, sure. Okay, go on.
4 to the -6.
And D?
5 to the 12.
And is there any other way you could write C?
1 over 4 to the 6.
Well done. And so let me now jump back, way back. Oh, not that far back. So what will be this one here?
So t to the minus 6, t to the 6.
So t to
One-
the that's the same as what?
1 over t to the 6.
Yeah. Okay. Okay, exam question. Top right.
X to the 6.
And top middle.
H to the minus 6.
And how else can you write that?
1 over h to the 6.
Well done. I can raise indices to a power.
Tick.
Okay, let's try A. Sorry, even before A. Let's try this one up here.
Okay. 2 to the 3 times. So 2 to the 3 r to the 6.
And what is 2 to the 3?
8.
That's it. So 8r to the 6. How about A?
25x to the squared.
B? No, actually C.
9p 10 to the 10, q to the 8.
Well done. I think you're fine now. Okay, let's try top right.
So 20, no, 8 x to the 16, no, 18.
Yeah.
Y to the minus 3.
That's it. I can raise indices with 2 and 3 terms to a power.
Tick.
And if you can do 3 terms, obviously you can do 2. Okay. What is this one on the top?
25.
Yeah. What is 25? What's the one next one? 2?
25 to the 1, so 25.
Yeah. So that's 25 to the 1, which is the same as 25. So you get the same answer twice by multiplying something by itself. And so that tells you that they must be the same as each other. And so the square root of 25 is the same as 25 to a half. The square root of anything is the same as that number to a half. How about part 5 down the bottom?
Square root of 16, so 4.
Well done. Square root of 16 equals 4. So to the power of a half means square root. Okay, what would this first one be?
1. No,
10, yep. How about next one?
2 times 2 times 2. 8.
Next one?
8. Yeah. So then they're equal.
Yeah, so that's like 8 to the 1, which is just 8. And yeah, so the same thing. Yeah, they're equal. They're the same as each other. So something times itself 3 times gives you 8. Something else times itself 3 times also gives you 8. These must be the same as each other. And so to the power of a half is square root. To the power of a third is cube root. And so on. Okay, so the power a to the half is the same as the what of a?
Cube root.
This is a to the half.
Oh, square root.
Square root. A to the third is the same as the blank of a.
Cube root.
Yeah. So how about b? What is that?
20. Cube root 27.
And what's cube root 27?
3.
Yeah. How about part 3?
Minus cube root of minus 1. So, so just minus 1.
Yeah. Next.
Is it cube root of 1 over 1,000? Is that this 1 over 1,000? Or 1 over 10?
1 over 10, yeah, because if you did 1 over 10 times 1 over 10 times 1 over 10, you'd get 1 times 1 times 1 over 10 times 10 times 10. How about, sorry, any questions with those ones?
No.
Okay, let's try from part A.
So the square root of 36, so 6.
Let's say skip to C.
1 over 9, 1 over 3.
How about D?
4 over 5.
Over 5. How about F?
Minus 8, so minus 2.
And how about H?
Minus 4 over 5.
Yeah. Well done. Any questions with those?
Nope.
Okay. Okay, let's try both of these. Any idea about the first one? What does to the power of a half mean?
The same as the square root, so it'd be the 3.
Next one.
Also 3.
Yeah, that's it. I can raise indices to a fractional power.
Tick.
That's it. Okay, let's try B.
So to this, right, so, right. Just 27 to the third.
Yeah. How about C?
Squared.
So 10 squared would be 100. Theirs is 1 over 100.
One over two.
What is it that will make the reciprocal?
The flipped number.
What? So the power of what makes it reciprocal?
Power of itself.
So how about this one in the middle? Why did that become 1 over?
Because it was minus.
So let's say you had x to the minus 7. That's the same as... No, sorry. What if you had 1 over x to the 5? That's x to the power of what?
To the power of minus 5.
Yeah. So then using that, try C.
So to the minus 2.
Yeah, well done. How about D?
To the minus 1.
So to the minus, and then how do you get square root?
Minus 2.
That would be squared. To the power of what is square root?
To the power of 2.
That'd be squared.
To a half.
Yeah, and so this one is to the minus a half because it flipped it and it square rooted it.
Okay.
And how about E?
Three to the is it to minus
Yeah. What if it was square root of 3? What's that same as?
3 to the 3 to the third.
That would be cube root, square root.
1 over 2.
Yeah. And so root 3 to the power 7?
3 to the 7/2?
Yes, 3 to the 7/2, because you multiply them. Well done. Any questions there?
No.
Okay. Let's try A.
X to the 4/2.
And what is 4/2?
Half.
That's 2/4? 4/2?
2/1.
Even simpler?
Or 2.
Yeah. X squared. How about B?
9 x to the 2 over 2.
So another way to write this would be in a bracket 9x squared and then a half, like that. So instead of square root, writing in a bracket with a square of a half. What would the x part be?
X over, to the,
What's the rule for power to a power?
multiply them.
Yeah.
So 9x to the 1. No, yeah, 1.
Let's say x to the 1 or just x. And it is the square root of both of them, not just the x.
So 3.
Yeah, so 3x. Try part C.
4x to the 8 to a half. So then 2x to the 4.
Well done. And D.
4x to the 2 and then y to 3.
Got it. Any questions there?
No.
Okay, any idea how you do this? 5√5.
Would it be a fifth?
Another way to write this would be 5 times √5. How would you write each of those as 5 to the power of something?
Squared?
So 5 by itself is?
20, no wait. So 5, just 5?
So 5 by itself is the same as 5 to the power of what?
1.
And the square root of 5?
The half.
And so what do you get when you multiply these two?
A half.
5 to the 1 times 5 to the half?
25 to the half.
What would be a to the 1 times a to the half?
A to the 1.5.
Yeah. And so 5 to the 1 times 5 to the half?
5 to the 1.5.
That's it. 5 to the 1.5. And I'll just write it as 5 to the 3 over 2.
Mm-hmm.
Any questions there?
No.
Okay, tricky one. Let's try simplifying this.
To the 3
Mm-hmm.
x to the 4 and then y to the 1.5.
Yeah. 0.5, and I'll just write it as y to the 3 over 2. You'll see why in a minute. Okay, I can raise indices with 2 and 3 terms to a fractional power.
Tick.
We did this one. Let's try this one up here. 25 to the minus a half.
To the half.
And so, final answer?
5.
Yeah. How about B?
B 8. No, so 1 over 64 to the 3rd, and then 1 over 4.
Well done. And last one.
1 over 9. Wait, no. So 3 over 5.
So it's 3 over 5 to the minus 1. We haven't gotten rid of the minus yet. Do you remember what we do if it's a fraction?
Do you change it into...
So what would the answer be here?
To the... don't know.
You might not remember. So earlier, do you remember what the reciprocal of 2 over 3 was?
3 over 2.
And so to the minus is reciprocal.
So 5 over 3.
Yeah. And the reason why the 1 over thing is the way it is because 64 is the same as 64 over 1. 25 is the same as 25 over 1. So you get 1 over 64, 1 over 25, and so on. That's where it comes from. Okay. Let's try this top one.
So 1 over...
There's no to the power of minus.
So would it be 60... 64 to the... oh wait, that's it. So, 4 and which is 16.
And how about A? And basically what this up here shows you is that you power the numerator and root the denominator. So you did the cube root of 64 and then you square it, and that's because you can split those into two separate things. You can undo the multiplying, because 2 over 3 is the same as a third times 2, or because 2 is the same as 2 over 1. Okay, part A.
3 squared, so 9.
Well done. And B.
So it'll be 16 to the quarter. Or
so you have to get rid of 3 things.
yeah. 1 over 16 to the 3/4. And then 1 over 16 to the quarter.
So you have to do the, what do you do with the 3, what do you do with the 4?
So you root the 4.
Yeah, so the 4th root of 16?
2.
Yeah.
And then cube it. So then 1 over 8.
Well done. So, and it's a good order to do them: the minus, the root, and the power. And rooting and powering are inverse of each other, so it doesn't matter what order you do them in. It's just that rooting makes the number smaller. What would be... Now, you did it already. Okay, exam question.
That the cube root of 27. So 3 to the power of 2, which is 9.
That's it. I can raise indices to a fractional power with a non-unit numerator.
Tick.
And I think I introduced one of those too soon. But anyway, oh, crazy town. Let's just try exam question. This one.
So 60. Would be 8 x to the 6 over 5. X to the 3.
Yeah.
5y to the 1.
So that would be if it was to the power of a half. This was to the power of minus a half.
Then 1 over that.
Yeah. And how do we do 1 over a fraction?
So 5y over 8x cubed.
Well done. Any questions with that?
Nope.
Okay. I can raise indices to a fractional and negative power.
Tick.
So that's as tricky as it gets. That's further maths, which you are not doing, I believe.
Nope.
I still like it all the same. Okay, what is A?
P to the 4.
Yeah. B?
18 A to the 7, and then B to the 2.
C?
9x.
That would be if it was squared. This is cubed.
27x to the 6, and y to the 9.
D?
4a to the 4 and b to the 5.
Question 2A?
4. Oh wait, no. So you have to do the root for 16.
Yeah. 4th root of
Yeah.
16?
Yeah. So 4 to the.
That's the square root of 16. 4th root?
2
Mm-hmm.
cubed, which is 8.
And B.
Cube root. Is it? 5
Yeah.
over 8.
Cube root?
4.
And this is to the minus a third?
So 4.
Yeah.
5.
4 over 5. Well done. And so you've done the further maths test, so you don't need to do the GCSE test. It's much simpler. And so that was the same as the one we did. Yeah, well done, Hannah. Do you want to do... how did you find that?
It was alright.
That was grade 9 stuff. I was going to do standard form next. How does that sound?
Yeah.
Okay. Any questions for me in general?